The field of statistical inference consists of those methods used to make decisions or to draw conclusions about a population. These methods utilize the information contained in a sample from the population in drawing conclusions. Statistical inference may be divided into two major areas. 1. Parameter estimation is a statistical method used to estimate the unknown parameters of a probability distribution from a set of data. This involves selecting a statistical model that best fits the data and using the observed data to estimate the parameters of that model. The most common method used for parameter estimation is maximum likelihood estimation, where the parameter values that maximize the likelihood of the observed data are selected as the estimated parameter values. Other methods include Bayesian estimation, method of moments, and least squares estimation. 2. Hypothesis testing is a statistical method used to test a hypothesis about a population parameter based on a sample of data. The process involves setting up a null hypothesis, which is a statement about the population parameter that is assumed to be true, and an alternative hypothesis, which is a statement about the population parameter that is being tested. A test statistic is calculated from the sample data, and the p-value is calculated, which is the probability of observing a test statistic as extreme or more extreme than the one calculated, assuming the null hypothesis is true. If the p-value is less than the chosen significance level, typically 0.05, then the null hypothesis is rejected in favor of the alternative hypothesis. If the p-value is greater than the significance level, then the null hypothesis cannot be rejected. In statistics, a sample is a subset of a population that is selected for analysis. The sample is used to make inferences about the population, which is the entire group that the sample is drawn from. The goal of statistical inference is to use information from the sample to draw conclusions about the population. A parameter is a numerical value that describes a characteristic of a population. Parameters are typically unknown and are estimated using sample data. For example, the population mean is a parameter that describes the average value of a variable in the population. The population standard deviation is another parameter that describes the spread of the variable in the population.
When we take a sample from a population, we can estimate the population parameters using sample statistics. For example, the sample mean is a statistic that estimates the population mean, and the sample standard deviation is a statistic that estimates the population standard deviation. The process of using sample statistics to estimate population parameters is called parameter estimation. In summary, a sample is a subset of a population that is used for analysis, and parameters are numerical values that describe characteristics of a population. We use sample data to estimate population parameters through parameter estimation. In statistics, we use samples to make inferences about population parameters. We typically use sample statistics as estimators of population parameters. For example, if we want to estimate the population mean, we can use the sample mean as an estimator of the population mean. This process is called point estimation. The sample mean is a point estimate of the population mean, denoted by the symbol mu. Similarly, the sample standard deviation is a point estimate of the population standard deviation, denoted by the symbol sigma. However, since the sample is only a subset of the population, the sample statistics may not be exactly equal to the population parameters. Therefore, we need to use inferential statistics to determine how confident we are that the sample statistics are close to the true population parameters. By using appropriate statistical methods, we can estimate the population parameters with a certain level of confidence. This process is called parameter estimation. The goal of parameter estimation is to find the best estimate of the population parameter based on the information available in the sample. Suppose that we want to obtain a point estimate of a population parameter. We know that before the data is collected, the observations are considered to be random variables, say x1, x2, x3. Therefore, any function of the observation or any statistic is also a random variable. For example, the sample mean x and the sample variance S2 are statistics, and they are also random variables.